Hello and welcome to episode 2 in the series Calculus 101. And today I'm going to be formally defining the limit. This formal definition basically is how the limit was originally proposed. How was it thought of? This definition is also known as the Epsilon-Delta Limit Definition. Let's get started. So this is a function right over here. It doesn't really matter what the function is. I'm not going to rigorously define it. Let's just say this is what it is. And there's an undefined point right over there. Now, technically speaking, the undefined point is quite unnecessary. It's not very important. But for the sake of the explanation, let's go by it. So this point right over there is x equals a. And that point will obviously have a corresponding f of x point, which is f of a. So let's call f of a L. Let's just call it L. So what can we say about this point? We can say the limit as x approaches a of f of x equals L. So what I want to do now is simple. I want to get extremely close values to L, but I can never equal L, once again, because it's undefined. So what I will do is take corresponding x values very, very, very close to A, so that I can get very, very, very close points to L. Let's say I take a point here and here. Now, once again, technically they're not very close at all, but just for visual purposes, this is definitely going to help. Now, once again, I will obviously have corresponding f of x points. Let's draw them right over here. So, I am going to call this distance from A delta. And I'm going to be calling this distance from L, as you guessed it, epsilon. So now I think you can really understand where the term Epsilon-Delta Limit Definition comes from. So therefore I can say that this point right over there is A plus delta. This point right over here is A minus delta. This point is L minus epsilon, and that is L plus epsilon. Pretty straightforward. So what I want to do now is make a game. This game is going to be consisting of 2 players. The first player will tell the second player, I want to be within 2 units of L, or 1 unit of L, or 0.01 units. You get the point. The first player will tell the second player how close they wish to be to the point L. Once again, remembering that they can never equal L, and that point will be epsilon. Now, once the second player knows what the value of epsilon should be, he or she is going to calculate the respective value of delta, such that if there are any x values within this range from a minus delta to a plus delta, there will be a corresponding f of x value within the range of L plus epsilon and L minus epsilon. What? Okay, that was a little bit confusing, so let me try and rephrase that in the best way possible. The aim of the game is to get as close to L as the first player dictates. The first player will be like 5 units close to L, and the second player will then calculate the value of delta such that that can be possible. So if, let's say, I give a value of epsilon like 2. Let's say L is, I don't know, 3, and epsilon is 2. So this is 5, and that is 1. Just making up random values over here. So what the second player now must do is find a value, calculate a value of delta, such that if there are any x values in the range of delta, this entire range right over here, there will be a corresponding f of x value that is within this range. Think about it. If, let's say, I just let delta equal anything, like let's say I let delta be over here, for example, this is completely incorrect, because now the corresponding f of x value will be here, which is not in the range of epsilon. So what I have to do, or once again the second player, is calculate the value of delta so that any x point will be in this range. So what I've done over here is hopefully given you a little visual representation. All the green lines represent the range of epsilon. And all the blue lines, and no, it doesn't really look blue because my marker is apparently out of ink. All the blue lines represent the range of delta. So, if I choose the correct range of delta, any point, x point, within this range, right over here, will have an f of x point that is within this range. So these 4 squares right over there will be covered. I know this has been a little confusing to understand, and even when I first understood it, it was extremely confusing. I really do hope I am helping you out. So now what do? We have to restrict x in such a way that it can only exist between these points. So how do we do that? So how do we restrict x? Well, the first thing we must see is that we want x to be in the range of from here to here. So let's say x is right over there. If x minus a will be this distance, is less than delta, then that is correct. But what happens when x is over here? The value is going to be negative. Well, that's okay. We can simply correct that with an absolute value symbol. So we can say that the absolute value of x minus a must be less than delta. Voila. But we are not done, because now what we have to do is restrict f of x. Or not really restrict it, but we have to be given the information that, see, we want this value of epsilon, so calculate the value of delta. So what we have to do is, once again, the exact same thing. The absolute value of f of x minus L must be less than epsilon. However, that's not yet complete, because this is only true when this is true. This will hold true that f of x will be in the range of epsilon right over there when x is in the range of delta. Ta-da! And we are pretty much done with the definition. So hopefully you understood a little bit about this, since it is quite confusing to understand. Now typically I would have done a few examples of the limit definition and proving limits using the limit definition in this particular video, but since I'm cutting it quite long, I don't want to strain too many of your minds. Your mind is like an oyster. Anyways, thank you so much for watching. Hope you enjoyed it, and until next time, stay sharp.